Welcome to Get Your FRQ On. This question is from 2025. It's question 1 and it is calculator active. In the question stem, we've got an invasive species of plant appearing in a fruit grove at time t equals 0 and it begins to spread. We're also provided with a function c of t that models the number of acres in the fruit grove affected by the species t weeks after the species appears, and we're provided with a function c prime of t that we will use for the rate at which acres are affected. In part A of this question, we are asked to find the average number of acres affected by the invasive species from t equals 0 weeks to t equals 4 weeks, and to show the setup for our calculations. The average number of acres affected from t equals 0 to t equals 4 weeks can be found by evaluating an integral with an average value form. We're going to get the integral from 0 to 4 of c of t dt, and we're going to take 1/4 of that since 4 is the length of the interval. And since this is a calculator active question, we're going to use our calculator. 1/4 the integral from 0 to 4 of c of t dt is 2.778 acres. Don't forget labels. And so we conclude that the average number of acres affected from t equals 0 to t equals 4 weeks is 2.778. In part B of this question, we are asked to find the time t when the instantaneous rate of change of c is equal to the average rate of change of c over the interval from 0 to 4, and again to show the setup for our calculations. First, we begin by calculating the average rate of change of c over the interval from 0 to 4. That's going to get us c of 4 minus c of 0 over 4 minus 0. That turns out to be 5.128 all over 4, which is 1.282. Don't forget, this is a calculator active question, so you can use your calculator to evaluate c at any value that you want. Now that we know what the average rate of change of c is over the interval from 0 to 4, we need to find and solve when c prime of t is going to equal 1.282 on that same interval. And since this is a calculator active question, we're going to use our calculator again. It turns out c prime of t equals 1.282 implies that t is equal to 2.154. And I guess that would be weeks. In part C of this question, we are asked to write a limit expression for the end behavior of the rate of change in acres affected and to evaluate that limit. Well, we're given c prime of t, so we're going to take the limit as t approaches infinity of c prime of t. That's the limit as t approaches infinity of 38 over 25 plus t squared. And that's just going to equal 0 since the denominator is going to approach infinity while the numerator remains constant. At t equals 4, some remedial action are taken, and the number of acres affected for t equals 4 to 36 weeks is modeled by the function a of t equals c of t minus the integral from 4 to t of 1/10 the natural log of x dx. And we are asked to find the time t at which the function a will achieve its maximum value and to provide justification for that answer. First, we note that a prime of t is c prime of t minus the natural log of t all over 10. And since we're given a function c prime of t in the question stem, we can assume that c prime of t exists for all t. This implies that c of t is differentiable on its domain. This means that the extreme value theorem is in play, so the function a will attain a maximum value at either t equals 4, t equals 36, or some value of x between 4 and 36. such that a prime of x is equal to 0 and a prime of t changes from increasing to decreasing at that point. Using our calculator, a prime of t equals 0 implies that t is 11.442 weeks. Evaluating the function a of 4 is 5.128, a of 36 is 1.743, and a of 11.442 is 7.317. And from these values, we can conclude that a will attain its maximum value when t is equal to 11.442 weeks. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.